Hello, hopefully you can still hear me over here. My name's Paul. I am a geologist. I work for a company called Fugro. Geology is the study of the earth. There's many different jobs and occupations that you can do after studying a career in geology. Today I've selected one of the fun topics of geology, the one that everybody likes, a lot of TV shows about and a lot of interest, and it's volcanology, which is the study of volcanoes. I'm going to do a little bit of a presentation that hopefully you'll be able to see on the screen, just to give you a little bit of background, and then we're going to do two experiments. One is I pre-made a volcano, and I'm going to do an eruption. There is a task sheet on how to do it, which you might or might not have got. You might have already built your volcano and be working along with me. I'm not 100% sure. If you are, make sure you're outside because it will get messy. And then hopefully all of you have got all of the activities which were listed, which included a catch tray, a tray to rest, a bit of paper, some wood to rest it on, and 3 different liquids. So the liquids that I have got for the experiment later is some washing up liquid, some honey, and some yogurt. But we'll come to that bit a little bit later on. So if you've got all of that equipment, excellent. Just stay tight for a couple more minutes, and then we can do the experiment along with myself. Let's see if this works, just so you've got a bit of things, a bit of a close-up action of me. Sorry for that one. I will keep talking. So as a geologist, you get to travel the world quite a lot, depending what section that you're in. I'm an engineering geologist, so I look at the beneath the earth, at the soil and the rocks, so that we can understand before we build houses, or we build roads, or we build anything, basically, what the earth, what the soil and rocks is underneath, so that we can make sure that the buildings don't collapse, the tunnels don't leak of water, or if there's a natural disaster such as an earthquake or a volcano, that the structure's not going to be affected and still going to stand. Volcanoes, hopefully everybody here knows what a volcano is. Some of you might have been lucky enough to see some. So the volcanoes, you get different types of eruptions. You get the lovely eruption, which is full of energy, and the lava and the molten rock explodes out of the volcano. But then you also get some volcanoes where the lava and the eruption is just a slow, steady sort of bubbling of the lava up and over the rock as it goes. What is a volcano? There we go. It's just an area which has got a flue or a chamber where it allows molten rock to escape up the surface, up to the surface, through the crust. And then we get 3 different types of volcanoes. We've got an active volcano, which is the active ones which you see in Hawaii, Iceland, and places like that. Get a dormant volcano, which is a volcano that hasn't erupted in the last 10,000 years, but has still got the potential to. So they've still got a magma chamber, and the flue that the magma rises to the surface is still intact, or still there. It just hasn't actually erupted in the past 10,000 years, but it could do any time. And then you get extinct volcanoes. So these are volcanoes that haven't erupted for longer than sort of 10,000 years, or that we know that the magma chamber's cooled or moved, or the rock inside of the chamber's cooled and becomes solid, and a granite or a gabbro is there. Within the UK, we only have extinct volcanoes. So if anybody's been up to Edinburgh and Arthur's Seat, that is an extinct volcano. If you've been over to the Lake District and been on Helvellyn, that is an extinct volcano. Snowdonia is another one, just to name a few. There's a few more up in Scotland as well. So although we haven't got any active volcanoes, there is still extinct volcanoes within the UK. This is a volcano structure. So as I said, we've got the magma chamber, which has got the molten rock at the bottom. You've got vents which take the magma up to the surface. You've then got the crater. You can then get things like volcanic bombs, which are cooled rock which get expelled from the volcano as it erupts. You then have ash and steam and gas that also comes out. So there's a lot of different activity that's going on within the volcano as it erupted and a different structure. Here we go. Why do the volcanoes erupt? Because the magma is collected in the magma chamber. As magma is added to the pressure, it increases. It causes the rocks to fracture. So often around the volcanoes, you get things called sills, which are little cracks or little fissures in the ground that the molten rock has forced its way through. The magma is less dense than the surrounding solid rock, so it rises. So it's an easier way to sort of push itself up. And then it erupts on the surface through either lava, ash, or gas. And there's different ways and different materials that cause the different types of explosions. Where do volcanoes form? So these are the plate tectonics that are around the Earth. We've shifted it a little bit, the classic view of the Earth. So the UK is now further to the right. That's just to show you the Pacific plate and the ring of fire. So all of the little triangles that are on this map, if you can see it, but you can see the circle in the middle of the screen there. That's the Pacific Ocean, and there's a ring of volcanoes that go all the way around, and that's where you get Hawaii and various other famous volcanoes. A few different ways on how the rock gets melted. So as the tectonic plates move, they either pull themselves apart, which exposes the magma that then rises to the surface. That's shown here. You then get continental drift. So the crust, or the bit of the earth which has got the land, crushes into the continent shelf. So the crust underneath the sea, and pushes it underneath it. As it gets pushed underneath, that it then warms up, gets hotter, under pressure, melts the rock. The rock becomes the magma, and then the magma needs to be escaped somehow, and then it comes up through a vent or crack in the surface and creates a volcano. You've then got convergent boundaries, which is very similar to the continental plate in the fact that the two plates have met and one's pushing below the crust into the Earth's mantle. You then get hotspots. This is like Hawaii and some archipelagos, and often some of the volcanic islands are formed because they are hotspots, and it's just the magma chamber that's underneath the ground, and it builds up, then and it finds a crack, and it either forms a new island, such as Hawaii, as it explodes, and then as the continent and the plates move, the hotspot moves, and then you get the various different islands that are formed. So the Canary Islands are another example of a hotspot of volcanoes. It's been one magma chamber that erupts periodically. It could be every 5,000 years, 10,000 years, or whatever in between. And it just depends on whereabouts the tectonic plate is at the time of the eruption. So if it forms a new island, or it just goes through an existing vent from the previous. There we go. So there's the hot spots, and there's it all moving around of the Hawaiian island chains, just as I've explained previously. Mentioned there's different types of eruptions. Everybody, my favourite anyway, is an explosive eruption where there's a lot of material, a lot of silica in there, and it's how you see the mountain, the lava fountains and things like that. But then you get the effusive, where it's the slow lava that sort of pushes itself, and you get that often. You can get that in Iceland, and you can get different things, so like volcanic pillows and other sort of formations that are formed because of the way that the lava forms. So this is just a quick way of making our own volcano. I know I haven't got you guys to do that today, or if you have, excellent, you can join in. But if not, you can do this on your own, in your own time, and let's see. But what we'll do is we'll explode the volcano here. So I'll take it off the slideshow. If I can work out how to do it. there we go. So excuse me, so you're back to me now, back to the video, back to my garden. So here we go, we've got my volcano over here, which hopefully you can see. I've already pre-mixed the material, so within this jug is a nice red liquid, which has got washing up liquid in it. It has got water, it's got baking soda, and it's got a little bit of food colouring just to help it, well, just for the effect. So I'm just making sure that that's nicely mixed up again, and I am going to pour it into my volcano. Obviously, a real volcano, you don't have to pour the material in, but for this you do. I'm going to pour all of that in. There we go. It's lovely and frothy. And then now I've got some vinegar. This is just normal vinegar, the same vinegar that you put on your fish and chips. Now that's added into your volcano, you now add. Whoa! Before I could even get it all in, the volcano's exploded. It's got a really effervescent. So it started off explosion as it came up, as I was still pouring the vinegar in. Make sure you do this outside because you get a very strong vinegary smell. And there you go, and as it bubbles up, the volcano and the lava's all flowing down the sides of the volcano, which again is good for the different models and things like that as we do it. So there we go, you can do that, it's great fun as you do it, and you can do that in your own time, or hopefully some of you might have done it now as we've been going along. I'll just nip quickly back to the presentation before the next experiment. Here we go. So you get the different types of volcanoes from that. You get shield volcanoes, which are probably often from the slow, non-explosive explosions, where the material is quite viscous and it just slowly bubbles out and keeps quite a flat shield shape volcano. There's some examples there. Then you get your composite volcano, like Mount Fuji in Japan, which is almost like my model here, really steep-sided volcanoes that often quite a fast flow, as mine was. It flew quite fast down the side of the volcano to the bottom, so it creates the steep sides of the volcano. The different materials that are in the magma or the melted rock, so it depends what's melted to create the liquid molten rock within the magma chamber. Depends on the type of explosion that you have. So basalt there, it's got a low viscosity, where the andesites are medium, and then the rhyolites are high viscosity, so that moves different. So it depends. You can often tell by the shape of the volcano if it's a shield or it's a composite, what the material and how much minerals are in the lava that you find. What we have there, I'll come and I'll show you some rocks once I get off this slide. There's different types of lava, and they've all got cool names. There's two different types of names. There's Bahui lava and Aha lava, and I'll go to that. And then this is the activity that we'll finish off with. I hope you've all got all of your material, and that's the end of the slideshow. So I'll finish that off, and then I'll return to me, which I know you're all thrilled about. So there we go. So I mentioned about the different types of lava that you've got. So there's this nice sort of dark reddy colour here that you'll be able to see. This is Aha lava. What we believe it was called Aha is because the Hawaiians, if they stood on it, they went Aha, 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 and that's how it got the name. The other name of the lava that you've got is called Pahui, which means rope-like, and I'm not sure if you'll be able to see that on the camera, but this is Pahui, and you can see the sort of strands of the rope a little bit up there. There's a bit of Pahui lava. You can then get other different types. There's a bit of andesite, so anybody who plays Minecraft knows about andesite, and this just shows that it was really, really cooled quickly. So it's probably either erupted underneath a glacier up in Iceland or something like that, and it cooled, the molten rock cooled really quickly, so the minerals didn't have time to grow, or it hit water or something like that. You can then get other, this is a bit of basalt with some olivine crystal in it, and you get other types of cool lava like that. So there we go. Cool, different types. So the experiment that we want to do, as I said, sometimes you'd want to know about the viscosity of the material. I think I'm cutting my head off here, but there we go. It's probably the best feature of myself. You want to know the viscosity of the material so you can tell how it's going to flow, and understand, you know, if you had a little village down at the bottom of the volcano, because often people live around the volcanoes because the soil's rich, so it's good for full of organic material, so it's good for growing crops and other foods, and the farmers like it, so often that's the case. So what we're going to do is, you've got your drip tray. Okay, I'm going to place that on the base. You're then going to use your tray and use a bit of wood, anything that you've got, just to pop your tray up so it's going down at an angle. Doesn't really matter what that angle is. Could be anything that you want. One thing that I like to do, if you get a chance, if I can find the ruler, is just draw a line anywhere on your bit of paper. Help if I had a pen that worked. Here we go, draw a line on your paper, and that's going to be your start line. Hopefully, because you're all in the scouting movement, you might have an actual stopwatch. I'm just going to use the stopwatch on my phone because I couldn't find where my actual stopwatch was, because I wasn't very prepared, but there we go. So what we're going to do is, you're going to take your different material, your different liquids. We've got 3. We're going to place them all on the start line, and we are going to start the stopwatch and see how far they move under the set time. So I'm going to start off with my yogurt. So we place a bit of yogurt here. Dump of yogurt on the start line. Then I'm going to use my honey. So I use a dump of honey on the start line. And then last of all, I've got some washing up liquid. And put a dump of washing up liquid on my start line. And it's already started to flow before I've even started my stopwatch, but there we go, and we start our stopwatch, and hopefully you can see there as the different liquids are moving down at different speeds. It's got, at the moment, the washing up liquid is really winning the race. It's going to hit the bottom, and it hits the bottom there, stop. So what I like to do is then measure the time. So that was under 20 seconds. 20 seconds, and from the start line up into the base is 26 centimeters. The honey in that time managed to go from 26 to 19, and the yogurt didn't move at all. So I'm just going to write the scores down there. So I've got the yogurt at none. I've got the honey 19, I think I said it was, and the washing up liquid 26 centimeters, and that was in 19 seconds. Now, as all good scientists know, you repeat your experiments, and the more times that you repeat your experiments, the better the results. So I'm just going to place that out of the way, put the rock on so it doesn't blow away, so I'll remember to pick it up later. Get another piece of paper. Get another piece of paper and draw a line on it. I've done this one quite high to the top now. Place with a piece of paper on your sort of securing tray. Well, let's do it again so that we can see just that it wasn't a fluke, that it wasn't just a random bit of washing up liquid that won the race, or a slow bit of yogurt. So put the yogurt on, put the honey, put a bit of honey on, and then a bit of washing up liquid. I'll start my stopwatch. There we go, and it's looking like the results are going to stand the same again, that the washing up liquid is winning the race. It's showing that it's less viscous, it's less thick, it's more runny, more sort of like water, so it's flowing quickly. So if that was coming out of the volcano, it would flow quickly and probably reach a wider area. If the volcano was a volcano of yogurt, as it erupted, it wouldn't flow down the volcano, it would stick there. So the risk to others, and sorry, as I was talking, the washing up liquid has won the race. Well, stopwatch there. I was getting excited explaining about it. We'll measure it again for number 2. So that took probably, with me talking, less than what it's showing on my stopwatch. But again, it probably took around, hopefully at home or online, that you were recording it better than me. But probably again about 30 seconds. And that time it travelled, drew the line higher, 28 for the washing up liquid. And then 15 for the honey. And I've lost my 15 for the honey. And then the yogurt hasn't moved at all. So if I was living next to a volcano, I would prefer to live next to a volcano of yogurt, because then, because of the viscosity, as the volcano erupted, it would all stay around the chamber and around the crater, and the effect, it wouldn't hit me, or it would give me enough time that when it did start, by the time it was going to hit me, I could get in my car and drive away, or move away and not be affected by the volcano. If I was living next to a volcano and it was honey that was coming out, I'd have less time to be able to move away, more chance that lava is going to flow down the volcano quickly and hit my house or capture me. And especially if I was living next to a volcano of washing up liquid, I would have hardly any time before that lava flew down the volcano side, captured me and killed me, or couldn't let me escape. So what's good, you can repeat this experiment as many times as you like, and then you can plot your results just on a nice little graph and do sort of time against length. If you kept the length the same, and just see as it went. And you can use different materials as well to see the different viscosities and to see the different flows as it goes. Obviously, water will probably be really quick because it's got a viscosity of nothing, because it's water, and that's the measure. And see what else you can do. Brings me to an end, really. Hopefully you've enjoyed my talk and the experiments. Hopefully, if you are interested, there's loads of things on the geological website, geosoc.org.uk, different fun activity sheets and things like that to do with volcanoes, and you can always go onto YouTube or other platforms and be able to watch volcanoes explode and do things like that. So thank you for your time. Hope you enjoy your virtual camp. Yeah, thank you.